Problem numbers 14 and 16, we're supposed to find the domain, discontinuities, intercepts, and also to classify the discontinuities as removable or non-removable. And if you watch the first few videos, you should be dialed in right now. We've got, we always have to factor and cancel. So the denominator is already just factored. We can't factor it anymore. But the numerator, we can factor out an x from both terms. And when we factor out that GCF of x, we're left with x plus 2. Therefore, we have a common factor of x plus 2. Before we do that, though, we really need to identify what the discontinuities are. So I got ahead of myself there a little bit. So the discontinuities automatically, before you cancel any factors, you have to identify that x is not allowed to equal 2. So we have a discontinuity at x equals 2. And we're going to classify that here in just a moment. And the domain would be, you get that for free really, because anywhere you have a discontinuity, well, that's an exclusion from the domain. So therefore, x is equal to all real numbers except when x is equal to 2. So x is not allowed to equal 2. And I apologize, you might have already caught that. I notice here I said 2, but I really mean the number that makes the denominator equal to 0, which is negative 2. So I'm sorry that you may have been struggling with that a little bit. So negative 2 makes the denominator equal to 0. Therefore, we have a discontinuity at negative 2. We also know that, again, that's an exclusion, so it's not a member of the domain. So domain can be any real number except for negative 2. And then let's go ahead and classify that. Notice that we already canceled that, so that would be a removable. And I'm going to use R for removable and NR for non-removable. And then it's a matter of us finding the intercepts. Now, when we want to find the intercepts, this is where we get our reduced version of our function. Notice that we cancel the x plus 2's. So really all we have left is y equals x. Also remember, the x can't be negative 2. So the y equals x is being the reduced version is how we have to find our x and y intercepts. If we let x equals 0 to find our y-intercept, we'll notice that when x is 0, y is 0. So the x and y intercepts are the exact same point. So if you were to look at the graph, by the way, of this, y equals x, except for when x is equal to negative 2, we get this little gap right there. And we just put a hole just to represent the point negative 2, negative 2. So that you didn't have to draw the graph, but if you drew the graph of y equals x, it would look like this, except when you have that original factor of x plus 2 on top and bottom, we know that x can't be negative 2, and that's actually what it would look like. So we haven't really talked about the graphs of these yet with a hole in them, and but that is what it would look like. A removable discontinuity at negative 2, domain all real numbers except for negative 2, x and y intercepts, same, goes right through the origin, and that would be a picture of what this graph would actually look like.